we're going to look at graphing exponential functions. There are several parent functions for graphing of an exponential function. What makes a function exponential is when the variable is the exponent. So it could be y equals 2 to the x. Maybe it's 3 to the x. Maybe it's e to the x. Maybe it's 1.6 to the x, and so on and so forth. All of these have the same generic shape. The only thing that's different are the values of y, obviously. But they all have the same y-intercept. They all have the same domain and range. They all have the same shifts. So let's just take a look at 2 to the x. If y equals 2 to the x, just plug in a couple points off the top of our head. X is 0, y is 1. For all of these functions, if x is 0, y is 1. All of these parents, non-shifted, all of these go through the point 0, 1. Now, of course, what's going to change is if x is 1, here y is 2, y is 3, y is e, which is 2.7-ish. Y would be 1.6. So I'm going to graph y equals 2 to the x. So if x is 1, y is 2. If x is 2, y is 4. If x is negative 1, you don't get negative 2. Be careful. If x is negative 1, you get 1/2. X is negative 2, you get 1/4. And you get what should be a nice smooth curve. All of these, the domain is all real numbers, also known as negative infinity to infinity. The range, it doesn't matter what you plug in for x, y is never going to be 0. There is no value that you can plug in for x that is going to make y 0. So the range is from 0 to infinity. And we have an asymptote, a horizontal asymptote, HA, at y equals 0. So it's going to be hard for you to see, but I am going to draw in an asymptote here. There are no x-intercepts. There are no x-intercepts. All of these functions have the same generic shape. Okay, so let's look to see what happens when you have y equals 1/2 to the x, 1/3 to the x, etc. 1/2, 1/3, 2/3, whatever. What happens when the base is less than 1? I'm going to do the same thing. I'm going to find the domain, the range, x-intercept, y-intercept, etc. Okay, still, if x is 0, y is 1. Same y-intercept as 2 to the x. Okay, and this time, if x is 1, y is 1/2. If x is 2, y is 1/4. If x is negative 1, y is actually 2. The reciprocal. Not bad for me. The domain is still all real numbers. The range is still 0 to infinity. The horizontal asymptote is still y equals 0. And there are no x-intercepts. And let me draw in that horizontal asymptote. The domain, the range for both of these, domain, the same, range, the same, horizontal asymptote, the same, etc. Okay, so there's a couple things that I would like to point out here. 2 to the x, 1/2 to the x are reflections over the y-axis. 2 to the x, 1/2 to the x are reflections over the y-axis. So I'm going to draw in 2 to the x on the same graph as 1/2 to the x. Okay, I'm just going to draw it dotted here. So this is 2 to the x. My little dotted function here is 2 to the x. Well, it has y, so they're reflections over y. Their x values are opposite. Their x values are opposite. When you plug in 1, you get 1/2. When you plug in 1, you get 2. Let me try that again. If you plug in the opposite value of x, you get the same value for y. If you plug in the opposite value of x, you get the same value for y. Well, how does that look? Take 1/2 to the x. Isn't 1/2 the same thing as 2 to the -1? And isn't 2 to the -1 times x 2 to the -x? And there you have it. 2 to the positive x is a reflection of 2 to the -x. You took the opposite of the x value and you got the same y value. So when you take the opposite of x, you get a y-axis symmetry. So let's take a look at another problem. If you have y equals 2 to the x and y equals -2 to the x, this is an x-axis reflection. When you have y equals 2 to the x and y equals 2 to the -x, this is a y-axis reflection. Okay, a couple things. The first is your book uses a for the base. Your book uses a for the base. So your book says y equals some constant times a to the x. This is how you were taught it last year, and this is how you're going to continually see it. So don't be confused when they're talking about a as a base, and we're talking about a as a lead coefficient. And b, the base is greater than 1. We call that growth or increasing. This is going to come up a lot in word problems. When the base is between 0 and 1, can't be or equal to. It can't be or equal to. We say that this is decay or decreasing. This is going to help us a lot in word problems. Okay, if I ask you to graph y equals 1/2 x plus 3 squared minus 6, let's say. This is a shift left 3, down 6, and this is a stretch from the y-axis. Your book also calls it a compression to x. A stretch from y is the same thing as a compress to x. If I gave you y equals 1/2 times the absolute value of x plus 3 minus 6, same thing, left 3, down 6, stretch from y. What if I gave you y equals 1/2 times the square root of x plus 3 minus 6? All right, you get the point? They're all the same. The shifts are determined exactly the same way. The only difference is the shape. This is a U, this is a V, this is half of a sideways parabola. So let's say I give you y equals 2 to the x plus 3 minus 6. Oh, that's a big number. We'll deal with the 1/2 in a minute. All right, so if I ask you to describe the translations, you've done this a gazillion times. Left 3, down 6, and I'll ask you to tell me the domain, the range, and the horizontal asymptote. Domain, x. Are there any restrictions on what x can be? Nope. So the domain, I can plug in whatever I want for x, -infinity to infinity. Normally, the range is y is greater than 0. For the parent function, the range is y is greater than 0. If I'm shifting that down 6, my range should be y is greater than -6. My horizontal asymptote should be at y equals -6. The y-intercept is no longer 0, 1, and this is going to have an x-intercept. So let's just take a quick look. Down 6. Oh, where's it? I'm going to draw the parent in dotted. So it's something like this. You do not have to draw in the parent. I think for many of you it helps. All right, down 6. So instead of going through 0, 1, it goes through 0, -5. The horizontal asymptote. I'm just going to take the point 1, 2. If I move that down 6, 1, 2, 3, 4, 5, 6. So that gives me the point 1, -4, I believe. And then let's see. Origin. Here. Oh, that's awful. That's pretty terrible. I missed most of my points. So this does have an x-intercept. This does have an x-intercept. How do you find an x-intercept? You make y 0, and that will involve logs. So we will hold off on the x-intercept until we review logs. Let's look at a function with e that has a lot harder shifts, etc. So let's look at the f of x equals 7 minus 3e to the 2x. All right, so the coefficients on x always mess you guys up. If it helps you rewrite it, this is -3e to the 2x plus 7. Plus 7. That's up 7. -3. This is a reflection over x. The 3 is going to make it a compression to the y-axis. It's going to make it a compression to y. Write that down over here. A is absolute value of A is greater than 1. That's a compression. When A is less than 1, that's a stretch. Okay, and then essentially you're taking the Y values and you're multiplying by -3. There was a problem that involved all the stretching, compression, etc. on the midterm. You had a hard time remembering what went where. Okay, the coefficient on X is 2. The coefficient on X is 2. Multiply A by 1 over that. Sorry, multiply X by 1 over that. Coefficient on X, you multiply the X values by 1 over that coefficient. So in this case, that is 1/2. And then it's E, which messes everybody up. E is just, it's the natural number. E is the natural number. It is used extensively in growth and decay, hence why we're talking about that in this section. It's also used in interest. So here we go. I'm going to look at the parent. Okay, so the parent goes through -1, 1 over E, 0, 1. All the parents go through 0, 1, and 1E. Domain of the parent, let me, oh, I don't know where I will write it. Domain of the parent is -infinity to infinity. The range of the parent is 0 to infinity. Horizontal asymptote is at y = 0. Asymptote, what you approach, but don't touch. All right, here we go. Let's start with 0, 1. It's by far the easiest one to do. Multiply X by 1/2. 0 times 1/2, who cares? -3, multiply the Y value by -3. So X doesn't change. Multiply the Y value by -3. Up 7 means add 4. There is my y-intercept. There is my y-intercept. Okay, so my range is either going to be 7 on up or 7 on down. And in this case, it's 7 on down because this is a reflection over the x-axis. So instead of looking like such, this one's going to look like such. It's going to go down instead. Okay, 1E. So 1, multiply that by 1/2. Your Y value gets multiplied by -3. Next. And then up 7. Okay, let me erase this. This is going to be -1/2. Multiply the X by 1/2. The coefficient on X is 2. Multiply by 1 over the coefficient. In this case is 1/2. Order of operations, multiply, then add. So Y gets multiplied by -3. 1 over E is -3 over E. And then add 7. I don't know where that is exactly, so I'm just going to sketch my graph to help me figure out my domain and range. I'm not going to worry about x-intercepts right now. We will worry about that in the next section. All right, so my y-intercept is 0, 7. I think I'm going to have to go by 2s to make this work. And now you know what? I can make it work. Me all this time to realize I made a mistake. -3 plus 7 is 4. -3 plus 7 is 4. Sorry about that. There we go. So this is wrong. So the range, the domain I should say, is still all real numbers. Okay, so if we have shifted this graph up 7, normally my horizontal asymptote is at 0. Now my horizontal asymptote is at 7. For the remaining points, so if I ask you to give me the exact value of a point on the graph, this would be it. This would be it. For graphing purposes, so I can sketch it, I did use my calculator. And so the 0.12 -3e plus 7 is about -1.2. Again, I just used my calculator. And this point right here is about 6.9, whatever. This is, you can see it's very compressed to the y-axis. I mean, your graph doesn't have to be perfect. So the range is -infinity to 7. And the horizontal asymptote is at y equals 7. So I would expect to see, these are the exact points. It's like using pi or √2. Those are the exact answers. And then use your calculator to find the approximate answers.